Hi, my name is Saleema Amershi. I'm a principal researcher at Microsoft Research AI, and I'm here to talk to you about why planning for failure is necessary for creating responsible AI systems. This is work I've been doing as part of Microsoft's Ether Committee, which is Microsoft's advisory council on AI and ethics. Now, we created this committee because, as we all know, AI is being used in more and more of our applications and services. But it's also changing how we interact with those applications and services and creating new challenges for people. And we see this in everything from humorous auto-completion errors to really dangerous situations where people have been harmed. So for example, when they can't effectively take over when their AI system fails, as in this example where an AI operating the semi-autonomous vehicle fails to detect an object on the road. Now, many of these challenges are created by various kinds of AI failures. And so in this talk, I'll explain how many of those failures are inherent in AI systems and some are unavoidable. Those failures are often also socio-technical in nature, meaning they're not just technical, and that's because they are ultimately deployed in real-world scenarios and will be interacting with people and impacting society. And so responsible AI is therefore really a process that needs to involve proactively anticipating and planning for these types of failures. Okay, so why do I think this is so important? So we recently started asking people who build AI systems what their perceptions are about AI biases, fairness, and ethical issues, the kind that you hear about in the news. And we heard some interesting and sometimes really alarming responses. So for example, if you ask AI developers and creators about issues like Amazon's recruiting tool, which showed a bias against women, a common sentiment we heard is what we call the "this is reality" argument, which goes something like this. There are a lot of people who do not see this as a problem. The attitude is that this is actually what reality looks like. Now, this is a dangerous sentiment because even if there is a gender imbalance in the engineering field, as in this case, it's incorrect to say that AI models represent reality. AI models are by definition a simplification of the world, meaning that it's difficult, if not impossible, to ever fully capture all the complexities of the real world. So let's look closely at this AI-biased hiring scenario. In this scenario, our goal might be to create a classifier that can distinguish between people you should or should not hire. Now, how you represent those people to the AI algorithm is really important. So in this case, maybe you only have access to two types of information, like the number of years of higher education that person has, and maybe their previous salary. So what this means is that you're missing a lot of important information that might impact whether or not someone will actually be a good candidate to hire, like their ability to collaborate or their life experiences. And you might be missing that information because a lot of that information is really hard to capture computationally. And so what the AI algorithm is going to do is it's going to do the best to learn a model based on the information you give it. But that information is often limited. So it's incorrect to say that this is reality. And it's important to challenge this argument, especially when AIs are used in real-life situations where people may be adversely affected. And it's because of this type of thinking that excuses our industry from addressing or taking steps to mitigate these types of failures caused by these limitations with AI systems. Now, another argument we heard a lot is what we call the "this is just math" argument. Here, this argument goes a little bit like this, where at the end of the day, the data is just aggregated and shown. It's not going to be wrong what they're going to see. It is still going to be right. We are not expressing opinions or anything. Now, the idea that because this is math, it must be right is again not true, and is also a dangerous sentiment because it can lead it can lend itself to a false sense of credibility, which can potentially have harmful results. So going back to our hiring model, AI algorithms are designed to learn models that generalize well to new data, while optimizing some objective function, like minimizing loss or errors on the training set. So in doing so, they're necessarily going to trade off errors and sacrifice parts of the input space to produce the best possible function. So in this case, the algorithm might first try this model, which has, say, 8 errors, and then it may try this model, which has 7 errors. And then it might ultimately choose this model because it has fewer errors. So the point here is that even if algorithms are just math, the math itself is designed to do the best under the circumstances. And in these circumstances, because AI algorithms can't fully capture the world, they need to allow for some errors. So ethical AI development really needs to include acknowledging this fact and working to systematically and proactively identify, assess, and mitigate harms that could be caused by such errors. Now, another example of something we heard when we talk to people about these types of scenarios is what we call the "there's no problem here" argument, which goes something like this. The other thing to note is that there's a lot of talk about machine learning models being biased, right? Is that how you say it? So there is actually no bias in our models just because it is very analytical. Now, again, it might be true that the model or algorithm is not itself encoding any bias, although as we've seen, the algorithms themselves operate on a simplified representation of the world and can make errors by design. But this still is just a reductionist view of AI systems. So AI systems are made up not only of models and data, but it's also made up of the infrastructure over which those models and data operate, as well as the interfaces users will be seeing and interacting with. And so even if there's no problem with the model or data itself, which likely there is, failures can still occur at any of these other sites and result in harm to people. So for example, studies have shown that in high stakes scenarios, like high stakes decision making, even just the length of an explanation in an interface can influence people. Meaning that regardless of whether the prediction itself is correct, people can be misled by an AI system even when they would otherwise not agree just because of the way it's presented to them. So it's important to think about these systems holistically and plan for possible failures that can occur at any of these sites. Okay, now I want to emphasize that it's not that the people who are saying these things don't care about people or society. In most cases, these just reflect a reductionist view of AIs as purely technical. It also reflects how AI is often taught in schools. So where people are given, for example, benchmark data sets or generic metrics to optimize, and the focus is on the model or the data. And that contributes to harms because it hides how difficult it is to think about what are the right data sets, the right metrics and interfaces, all of this other information that is needed to actually build a responsible system in the real world. Okay, so this is why it's important to think about failures, because they're often inherent and unavoidable in AI. And so responsible AI requires anticipating and taking steps to address these possible failures. Now, I want to emphasize that by planning for failures, I don't mean that we shouldn't do our due diligence to try to avoid or reduce biases and errors in our AI algorithms. What I'm saying is that even if we do this work, there will still be failures, and responsible AI requires designing safeguards for people to mitigate those failures when they inevitably occur. Okay, so how can we start thinking about failures or anticipating common socio-technical failures? So recently, we created these guidelines for human-AI interaction, which you see here. And these prescribe how AI systems should behave as a user interacts with them. And we've been using these guidelines at Microsoft to frame different types of socio-technical failures and help people think through and mitigate some of the issues that I've talked to you about. Now, I won't go into a lot of detail about how we created the guidelines. For that, you can read our corresponding CHI 2019 paper. But I'll just quickly say that we created these guidelines by going through 4 rounds of iteration and evaluation and testing them with over 60 user experience practitioners across the company. We've also since been using them with teams across the company to help improve their AI user experiences. So all of this is to say that we didn't just make these up. We really endeavored to take a systematic and rigorous approach to developing the guidelines so we ourselves could feel confident in their effectiveness. So these are the guidelines again. There are 18 of them, and they can be roughly grouped into 4 categories based on when they would apply as a user interacts with them. Initially, during regular interaction, when the AI is inevitably wrong, and how the AI should interact with the user over time. Now, these are rough categories, not hard assignments, and we did that this way to make them easier to remember. Now, we didn't originally develop these guidelines with failures in mind, but we've been using them recently to help teams think through different types of socio-technical failures of AIs and to help them think of mitigation strategies to avoid those types of failures. So if I were to rename these categories, I would say these groupings tend to map to how to mitigate or avoid the following types of socio-technical failures: expectation mismatches, contextual mismatches, model errors, and evolution errors. Okay, so I'm going to give you a few examples of each of these types of categories, just to give you a sense of how these can help developers plan for AI failures. And I'll give you examples within the context of common AI-based products many of us use sometimes every day, including search engines, which use AI for processing queries, ranking results, filtering spam, voice-based virtual assistants, which use AI for things like speech processing, task and productivity support, sending you reminders, email systems that use AI for spam filtering, sorting emails, language processing, and social networks, which often use AI for filtering or sorting news feeds. And so the examples I'm going to give are based on our actual studies of the guidelines using real AI-based products across the industry. The first category is really all about setting the right expectations. And expectations are important because people often have unrealistic expectations about AIs because of how they're portrayed in the media and because of the lack of knowledge about how these things work. So let's take a look at these within the context of search engines. Now, even though search engines have been around for quite some time now, most people don't actually understand quite how they work or how accurate they are. In fact, studies of people searching the web have shown that many people think that everything is on the web, meaning that all knowledge in the world is available on the web. This is, of course, not true, and this misconception can actually impact how much people trust the results that search engines return. Similarly, studies have shown that if you ask people how search engines work, 1/3 of people will use terms like magic to explain it. Okay, again, this can impact how much people trust the results that they get. Now, you may be thinking, this is just search, it's not really high stakes, so if some people overestimate its capabilities, it's not such a big deal. Now, this really just depends on who is using the search engine and in what scenarios. So for example, I've been in doctors' offices where they've searched about what I've been asking about on the web, and it's taken them to a Wikipedia site, which they may trust just because it's returned by the search engine. And this type of thing can happen all the time. Now, what can you actually do about these types of failures? So one possibility for dealing with these expectation mismatch failures is to provide people with documentation. And this might work in some scenarios, especially for high stakes scenarios when people might be incentivized to read such documentation, but often people don't, so we recommend using it sparingly. Now, when I say documentation, I don't necessarily mean providing people with a manual. So in this case, in this example, we see even just the heading can be problematic or misleading. So this is Google search. And in this case, Google used to title the heading of some search results as in the news. But the definition of what counts as news was ambiguous to people. And they often would show results from unverified news sources. So since then, Google has changed the title here to say top stories. And this is to help fight misinterpretations of the results that people see. But there's also many other ways that you can set the right expectations. And so in our studies, we actually saw many different types of patterns for helping set the right expectations, like showing people examples of what a search engine can return or deal with well, or providing people with controls over the search engine results. So for example, you can filter search results based on different types of sources, like news sources or videos or images. Okay, so the point here is that for each of these guidelines, there are many ways that you can actually implement them. And this is a time for people to get creative about how they can implement these guidelines in their different AI systems. Now, you may be thinking, aren't these guidelines important for all computing systems, not just AI? And I would say yes. And in fact, when we developed the guidelines, we actually included guidelines that were either specific to AI or particularly important or challenging to create for AI systems. So for example, setting the right expectations is particularly important for AI systems, as I said earlier, because AI systems will make mistakes. And they might actually behave unpredictably in new situations, making it somewhat difficult to convey the right expectations. Now, the next category is all about context. And context is also important for AI because AI systems make inferences about people and their needs, and those needs really depend on the user's environment, their current task and attention, as well as the larger social and cultural context in which they're operating in. And contextual mismatches can actually result in harms to people. So let's look at this within the context of proactive voice-based virtual assistants. So these first two guidelines here are about a person's immediate surroundings. So imagine you had a proactive virtual assistant that could send you reminders when they're due, such as remember to call your mom. With proactive AI systems, it's important to really think carefully about when and where people will be interacting with these systems to avoid harms. So if, for example, your users are likely to be attending to critical tasks when they're using this system, like driving, untimely reminders like this could actually be dangerous to them. Okay, so again, what can we do? Well, in this case, we would want to understand and infer critical context and time services appropriately when you're interacting with a person. Now, these next two guidelines are about the larger social and cultural context in which people are using the AI system in. So in this case, imagine your proactive virtual assistant could show you the fastest route home. So you could ask the assistant, what is the fastest route home? In this example that we actually tested in our studies, we saw that in most cases, people couldn't see how this could fail. And we heard things like information is not subject to biases unless you're biased against fastest routes. Except for one person who said that there's no way to set an average walking speed. The product assumes users to be healthy. Okay, so this is something that really opened up my eyes because it suggested that in order to address this type of contextual mismatch, it's really important to develop and test these AI systems with diversity in mind. Okay, the third category here is all about what to do when the AI model itself is inevitably wrong. And now I can't stress this enough, your AI is going to be wrong. And if there is one thing I'd want you to take away from this talk is that your AI will be wrong. And so it's important to include mechanisms to reduce the cost to users when this happens. Okay, so let's look at this category within the context of email clients. So many email clients now have intelligent features like the ability to sort important from unimportant emails. So the first two guidelines here are really about how to deal with false positive and false negative errors. Okay, so in this scenario for email clients that can sort emails in terms of important or unimportant emails, a false positive here would be flagging an unimportant email as important, and a false negative would be marking an important email as not important. Okay, so in this case, this is a common type of error, and some might be more costly than others. So for example, missing an important email from your boss could actually be very costly to people and cause harms. Okay, so in this case, a way that you would want to mitigate, or a potential way to mitigate these types of common errors, are to first estimate the costs of different errors to people, and then provide ways for them to correct the AI. So in this case, they may need the ability to move emails from one category to the next. So these and the rest of the guidelines in this category are really about dealing with different types of common AI errors, like false positives and negatives, or being partially correct, or being uncertain. And again, this category is really about estimating costs to users and providing different mitigations, or at the very least, an explanation of why the AI system behaved the way it did. So the final category here is all about what to do as the user interacts with the AI system over time. And this is really important in AI because one of the key benefits of AI models are their ability to learn and improve over time. But this can also be disruptive if it's not designed carefully. So let's look at this within the context of social networks that can automatically filter or promote content in your newsfeed. So I recently made the mistake of being on my social network and looking at a post that looked like this. After that, I was immediately bombarded with more and more inspirational content like this. And now I enjoy a good inspirational post once in a while, but this amount of sunshine and cheer was a little too much for me to handle. And whatever I did to try to make it stop didn't work. And I wasn't sure why it was happening in the first place. And all my attempts to redirect my newsfeed to content that I was actually interested in failed. Okay, so what's going on here? So here, my social network is clearly learning something from my behavior. So maybe I dwelled on this post for too long or interacted with it. Now that might be a good thing. Learning from user behavior can be good, unless the AI system is wrong and learns something I'm not interested in. So in this case, it really is important to update and adapt cautiously after learning from the user's behavior. So in this case, I was immediately bombarded with a lot of information that I didn't want to see. So this guideline is really about carefully choosing the rate and the amount of change that you include in your AI system to ensure a good user experience. Now, guideline 15 here, encourage granular feedback, is all about enabling a person to explicitly steer the system to what they might be interested in. So in this case, in my social network, I have the ability to like content, but I don't have an ability to dislike something, which may have helped in this scenario. So my social networking example made light of these evolution issues, but I wanted to give you a similar example that shows why these and the other issues that I've talked about today should really be considered social technical failures, because they can actually result in harm to people. So this example comes from a woman named Jillian Brockle, who is a writer for the Washington Post and who lost her baby late last year. Soon after that, Jillian wrote an open letter to Facebook and Twitter to stop showing her baby-related ads. In this letter, she goes on to talk about how she tried to make the ads stop, but was unable to do so. And since then, Facebook and Twitter have apologized for the incident. Okay, so let's look closer at this example. In this case, the social networks likely learned something from Jillian's behavior to learn that she was pregnant. but then never learned that she had miscarried, and so started to show her undesirable information, or ads in this case. Now, Jillian goes on in the article to talk about how she could dismiss individual ads, but she wasn't able to turn off this type of ad completely, which is what she really wanted to do. Furthermore, she wasn't able to steer the AI to show her different types of ads. So to summarize, planning for AI failures is our responsibility. And that's because many failures are inherent in AI and are unavoidable. And so framing development around anticipating and mitigating these types of AI failures can help ensure safe, fair, and responsible use of AI in our society. And the guidelines for human-AI interaction are one way to look at these different types of AI failures and think about how to mitigate them before deploying in the real world. So thanks for your time.